Hi Professor, my name is Wen Shi. This is a presentation of my final report, which is about the mass transit railway system, which is known as MTR in Hong Kong. And let's have a quick overview of our contents. I'm going to cover 4 parts: introduction, system design, models for economic evaluation, and decisions on the risks and uncertainty. The first part is a brief introduction of MTR, which is one of the world's leading railway operators. MTR was established in 1975 by the Hong Kong government with the goal to construct an urban metro system that satisfies Hong Kong's current and future public transportation requirements. In 2007, another government-owned railway operator was merged into the MTR, and in addition to the railway service, MTR expands its railway-related business in a wide range of fields. Currently, MTR owns 9 railway lines with a total route length of 177 kilometers and about 2,000 train cars operating 19 hours every day. The merge in 2007 brought new growth opportunities to the MTR Corporation's business in and outside of Hong Kong. In addition to the 9 railway lines, MTR operates a light rail network and the Airport Express. To meet the fast-growing population needs, there are 4 ongoing expansion projects. My project will focus on the construction of the Southern Island Line East. And this is the route map for SILE. Now I will discuss about the system design, including conceptual design and preliminary system design. For the conceptual design, we have the following considerations. The first consideration is need identification. We need to construct a medium capacity railway that connects the current MTR station from downtown to the southern district of Hong Kong. We need to meet current and future transportation requirements of 350,000 residents and the working population in the southern district. And we also need to promote tourism development and economic activities in the southern district. The next consideration is feasibility analysis. The current MTR station, Admiralty, will include a new island platform for interchanging from current lines to SILE. And the 4 new stations will be constructed, and generally speaking, the construction of the line will be beneficial to the growth in the tourism in the southern district. And we have the following operation requirements, and we will go through them one by one. The mission of the project is to fulfill public transportation needs from central Hong Kong to the southern district, reduce travel time from the southern district to CBD, and promote tourism development. We have two important performance and physical parameters: peak hours train frequency and journey time between stations. The minimum peak hours train frequency should be 3 minutes, and the journey time between stations should not be too long. Operational deployment requires that the new stations will need to be located near tourism attractions to shorten the tourists' total journey time. To satisfy the future growth in tourism after the line is opened, new hotels will be built and the ocean park will be redeveloped. The Southern Line East must be designed to have a life cycle of at least 20 years. SILE is a medium capacity system and will use 3 car trains. The line requires shorter platforms and smaller stations, while maintaining peak hour train frequency similar to the other MTR lines and daily operation time of 19 hours. The train requires regular maintenance. The train depot located near Wong Zhong Station Both the underground section and the viaduct section need to be maintained regularly. And for not interrupting operation, maintenance can be scheduled during closed time. SILE is a project under the Environmental Impact Assessment Ordinance that determines ways to minimize the project's potential environmental impact. The construction of the new stations and railway facilities have green elements in their design, such as vertical greening, and dedicated applied research should be conducted to the project. A feasibility study of the line should be conducted to look for cost-effective option to improve the system. The study should also evaluate the external benefits of the project and its impact on the other models of public transport. Study of the current MTR lines and passengers along the Southern Island East should be conducted to determine the car capacity and minimum peak hour train frequency. The fully automatic operation system is used in maintenance and support in that it enhances railway service with a higher level of reliability and more flexibility in train deployment. And trains will be operated under the Operations Control Center, OCC. OCC obtains real-time information about train operation and the situation inside train compartments. During most emergencies, train services could be resumed by control from OCC. Besides, OCC can arrange spare trains to serve passengers to cater for any upsurge in patronage. And the typical TPMs for the system including route length, car capacity, average or maximum speed, peak hours frequency, journey time, mean time between failure and mean downtime. And next, we proceed to preliminary system design. We will go through all these considerations one by one. Type A system specification will specify the construction of the five stations. Type B development specifications will specify stations facilities and FAO OCC applied in the system. Type C product specification will specify train features. Type D process specification will specify peak hours, train frequency, and other TPMs that should be tested and evaluated. Type E materials specification will specify inner facilities of the train and building materials. And functional analysis will analyze in the subsystem level. One major subsystem is trains. We already know that the SILE is a medium capacity railway with streetcar trains. The train compartment is approximately 2.8 meters wide with a height of approximately 2 meters. It will also include the following inner facilities. Another major subsystem is the stations. The existing station Admiralty will be expanded into a strategy railway interchange for 4 MTR lines. The 4 new stations each will have facilities that provide a convenient and efficient railway service to residents in the surrounding neighborhood areas. And self-service points, kiosks, and public toilet facilities will be available in all the stations. And we have several points for preliminary design criteria. First, we have to design for interoperability. We need to ensure interchange from Admiralty Station to other MTR lines. Secondly, for sustainability, the South Island Line East should be a medium capacity railway with streetcars because of the relatively fewer passengers in the Southern District. And the FAO will be introduced in the Southern Island Line East to improve railway service reliability. For maintainability, we have train depot in Wang Chonghang Station, keep spare trains for replacement under the arrangement of OCC. For safety, we have CCTV cameras installed in each train compartment for control staff to monitor the train. And finally, for affordability, a total budget of the construction cost and operation costs will be made. These costs will be well contained in relation to revenue growth. Operation margins will be maintained at a satisfactory level. Trade-off studies is used in the route determination. The original proposal of the South Island East will be a semicircular line with 9 stations intended to serve the southern end of Hong Kong Island towards Aberdeen. However, the original proposal has some major drawbacks, so the original proposal is modified for a more cost-effective line and tackling all the drawbacks. The current proposal transfers the western section of the South Island to the western section of South Island Line. The South Island Line if will be a medium capacity system, and the Wan Chai station and Happy Valley station are eliminated. And next we will discuss about models for economic evaluation. A railway is considered not financially viable if the present value of all its projected revenues falls short of projected expenditures. This shortfall is known as the funding gap, and we will now examine two simplified models of the system and find out the preferred model. The first model is the original model. The initial capital cost is 11 billion and the annual estimated economic internal rate of return is 5.2%. Under a 5-year schedule, the funding gap is computed by discounting all the yearly revenue to year 0 and computes the net cash flow. After calculation, the funding gap for the original model is 9.2 billion. The amendment model includes amendments in the design stages, including providing noise barriers for viaducts, expanding the Admiralty station to be an integrated station, making a number of amendments to the detailed design according to ground investigation. As a result, the initial capital cost is increased by 1.4 billion and the estimated economic internal rate of return is now 5.8%. By applying the same method as the original model, we get the funding gap of the amendment model is 8.8 billion. Since the amendment model has lower funding gap, we can conclude that the amendment model will incur lower funding gap as well as providing better service for the passengers. Finally, we will discuss about the decisions on the risks and the uncertainty. When new project is initiated, any new issues should be evaluated and identify significant risks to the well-being of the existing business. Currently, the significant risks managed by the company applied for the new line includes corporate reputation and trust, and an enhanced communication plan has been implemented to provide more timely and transparent information to stakeholders on key issues. Major railway service incidents. For individual incidents, investigations or technical studies were conducted to identify opportunities for continuous improvement. System crowdedness. Crowded trains and longer on-platform waiting hours are being managed to enhance customer satisfaction. Workforce transition and increased manpower needs. To manage the workforce transition and tackle manpower shortage, various measures will be considered, including proactive management sourcing, advanced succession planning, skill enhancement, and deferred retirement. New railway projects interfacing with the operating railway. This risk is being managed through strengthened collaboration between the operations and the project teams, including the implementation of risk control measures and surveillance and monitoring arrangements. And that's all for my project. Thank you. Hi, Professor. My